Welcome to the video series on circuit protection. And we're going to look at circuit protection, and we're going to start off with faults. We need to have a look at the types of electrical faults that you might find. The main three types that we're going to look at are earth leakage current, overcurrent, and short circuits. Earth leakage current is where a small amount of current is leaking to earth, usually milliamps. It might not seem like a bad fault, but remember, milliamps can kill us. The other thing is, earth leakage current usually causes damage which gets worse over time. And over time you end up with a bigger fault and a worse problem. It's enough current to cause a small amount of sparking which can set things on fire. You can see here a connector that I found in the course of looking for an earth fault, and you can see where the current has managed to create a path between phase and earth, and it was fizzing away. So it got to the point where obviously more than 30 milliamps was flowing because the RCD tripped. Next is overcurrent, and another word for that is overload, when too much current is flowing in a circuit, more current than the rated current of the circuit. Here's a 15 amp water heater switch. I went to this client's house. The problem was there was no hot water. As you can see, that this circuit has been overloaded and the switch is just completely melted. So the result often of overcurrent is heat, and heat can cause all sorts of damage. Short circuits, pretty dangerous sort of a fault to have. Thousands of amps often flow depending on the amount of power available from the supply. Current finds a path of very little resistance. It takes a short circuit rather than going the long way through the load, which would slow it down normally. And this short circuit might be between phase to phase or phase to neutral, whether it is directly to the neutral or through the earth. A lot of power, like I've said, and a lot of damage can be caused in a very short time. You can see here a set of circuit breakers that has had a short circuit in them, and they came from the Mount KFC. Electrical faults can have unwanted effects. The three electrical faults that we've been talking about can all result in explosion, heat, energy and fire, damage to cables and equipment, electric shock, electromechanical energy. So all of these faults are dangerous, and they're dangerous to us, dangerous to our livestock and property. Heat energy, as we said before, something's overloaded or a short circuit causes high current and it causes heat. Insulation can break down, it can become brittle after it's been heated, and when you bend a cable, the insulation might snap off, and we can either have fires or get shocks. Or if the heat is too excessive, the cable can melt together immediately and cause a fire. That's not such a good idea, is it? Damaged cables and equipment, obviously we're at risk of getting a shock from insulation that's damaged, or we could have a fire. Electromechanical energy. It's where conductors can jump, bus bars may bend and buckle. This is as a result of the magnetism that's formed around a current carrying conductor. This is particularly a problem where there's high current, and you might think of industrial switchboards where there are big copper bus bars feeding the distribution board, and a lot of current flows. In a fault situation, the magnetism around those conductors can be very, very strong, and in particular when there's two phases involved, they develop a magnetism which is pushing them apart very, very strongly. So they might rip from insulators and touch the metal of the casing, or they might touch another phase, and you're going to end up with a massive explosion or a big short. I've seen a large motor running a compressor which shorted between two phases, and 20 meters of the supply cable was ripped out of its fixings as a result of this electromechanical energy. Electric shocks, I think it probably goes without saying that they're dangerous to us, aren't they? If we let current flow through our body one way or another, it's going to hurt us. It burns us from the inside out. electricity is insidious. It's always pushing against the boundaries, and the moment you give it a chance, it'll flow. Next is fire. Electrical fires can be caused by electrical equipment heating up, too much current and bursting into flames, or arcs from one conductor to another, which catches something that's nearby on fire. You're hearing all the time on the news about another house burnt down because of electrical fault. And we as electricians, everything we do has a potential to cause a fire, and as a result cause death and injury to people. We need to be very careful what we do, and everything we do we need to do well to prevent this sort of thing from happening. Explosion, even worst case scenario. If we've got a short circuit, like we were talking about the bus bars and a big distribution board, if they touch together, you're going to have an explosion. And also if there's, for some reason around, an explosive atmosphere and some form of electrical arc, then kablam. This is a table of effects of faults on people and property. You might want to pause the video here and have a look over this table. The idea would be to understand what it's saying rather than memorizing the words. Memorizing the words is not going to help you when you have to, when you're faced with this in the assessment. But understanding what's going on here is what you need to do to pass this assessment. Well, that brings us to the end of the first video on circuit protection.